Hello, welcome to the Reconductoring Economic and Financial Analysis tool tutorial. This is the beta version of this REFA tool, and REFA is designed to help utilities, particular transmission planners, to better understand financial, environmental, and economic benefits of reconductoring using traditional conductors or advanced conductors, and compare reconductoring with other investment options, such as rebuild and voltage upgrade. This tool is supposed to be technology neutral, so we are just providing a tool to calculate and compare economic costs, but all assumptions should be transparent and easily editable by the user. Here we have the landing page of the REFA, and on the top left, we can choose our system of units, where imperial is our system of choice as predefined. The first thing the user has to do is to select a state, and the tool will pull a map in a few seconds of the existing transmission infrastructure. This transmission infrastructure will be help us guide our drawing. So by clicking on the right-hand side here, we can draw on the map where we want to reconduct our project, or if you want to design a new line project, it also works. So when we are done, we just double click, and what's going to happen is this button will become accessible. So we can click on Go to Project, and our environmental variables, such as the length of the line, the latitude, or the elevation, are pulled into our project information. We can edit those variables, so no worries with drawing very well on the map. This is purely for reference purposes. So we have this project information here on the left, and on the right we have our results. That I'm going to through those in detail in a bit. But let's look at the project information. We have general project information like power capacity, sag, ruling span, maximum span. We have the base conductor, and I come to those in a minute. We have the environmental variables, the loading conditions based on NESC standards, and the economic parameters such as conductors and towers lifetime, or cost of capital, annual inflation, cost of energy, and cost of congestions. Cost of congestions here is the cost of basically doing nothing, is the cost of not reconducting your line. And this cost can be, for example, if there is a market, can be the difference between the market prices on the adjacent nodes, the difference between the LMPs on the adjacent nodes of the line. So here you can put any number, and when you add actually an existing conductor, let's take for example the ACSR Drake, we can check here on the right-hand side. When you select Drake, we can see on the right-hand side how the existing conductor compares with the rebuild and reconductor. And you can see here in yellow the cost of congestion. So all these calculations are just the best option for rebuild and reconductoring, and they are compared based on the net present value calculation over an horizon that is specified here by the sliding bar. So when we see that the existing conductor is too congested and reconductoring is a better option, let's for example forget this conductor and impose different project options. For example, let's increase the capacity to 400 megawatts. So when we do so, our reconductoring project is still better than rebuild. And when we do go to our reconductoring project, we see that our ACSS is a better option when comparing to other conductors. that are ACCC or AECCs or ACCRs that are more expensive conductors. But when we bring the maximum span, for example, to 550, like we increase the span and we can reduce the sag, say from 10 to 8, what we'll see is that other conductors like ACCCs perform better in this particular application. We can look at things like sag. Sag here is calculated based on SciGrid Technical Brochure 325. And we compare currents. Current here is calculated based on the IEEE 738 from 2023 standard. And we can see here the current and capacity calculation. There is a slightly difference between the ACCCs and the ACC in terms of capacity, but the ACCC becomes a better option in the net present value calculation. But because the ACC has more capacity, it also allows us to integrate more renewables. So we can also check out the benefits of each conductor and compare those for this application. So here we have for different years of capacity expansion. For this particular geographical location, we take the cambium data set values. Cambium is a data set from NREL with different capacity expansion up to 2050. So we take those values and we calculate the for each load increase by 2050 or 2040, what is the amount of renewable integration associated with it. So when a conductor allows for more capacity, we assume that in a particular location, it will also allow for more renewable integration. And we do this calculation here and present the benefits and the corresponding CO2 emissions decrease as well. So, but when we go to our reconductoring options in our overview, where we compare, rebuild and reconductoring, you can also add the third option, which is a voltage upgrade. And let's, for example, upgrade voltage while keeping the same towers. Of course, let's say we're going to update to 345 and we'll add the cost of towers of $1 million and upgrading the towers, it's $10,000 per tower. And you can see the voltage upgrade here becomes an option as well. Of course, this option is slightly more expensive than reconductoring, but that's because we have not considered losses. When we consider losses here on the left, we can see that the voltage upgrade becomes a better option than the reconductoring or rebuild. And of course, for each of these options, we're going to have the least cost conductor that can perform this within each technical requirement that is imposed here in the project information. So the same thing for voltage upgrade. There are different conductors and different performers. So we can see here for voltage upgrade, it can go slightly lower again on the section going to an ACSR, where for reconductoring that ACSR is not possible. Only advanced conductors are possible. Of course, all of this depends on the underlying information. That information is it can be editable here by the user. It's here in the conductor database, what we are considering for this cost. This should be changed here, so the user can simply change by double clicking in this buttons, or it can also upload directly at the bottom of the page. It can upload its own, so we can download the template here, change the template in Excel, store it in CSV, and upload again its own table. Again, the objective here is just to provide the calculator. The underlying information should be input by the user, and we are just performing this comparison based on the information that is input by the user. So thank you for watching this tutorial. Reach out to us if you have questions or feedback, and hope you enjoy the REFA tool. Thank you very much.